Yeah,
I can help you, no problem, tomorrow session, okay? Or if you are
thank you.
available, uh, yes, we can do tomorrow, okay? You can connect, no problem. I will update you. Could you see?
Okay.
Okay.
Okay, thank you.
Okay, let's continue our discussion now.
Okay, you can start.
We are trying to wait. We are trying to configure OSPF authentication method today. OSPF authentication. Wait. Topic is what? Routing, protocol, authentication, and we completed our RIP authentication, EIGRP authentication, and now we can focus on OSPF. So what I'm doing into this design, I'm trying to advertise all the devices, both the routers R1 and R2. I'm trying to advertise in OSPF area 0. In OSPF area 0, let's create loop back again. We have a same design, 2.2.2.2/32/192.168.20.1/24. Let's configure IP address here. Wait. Win.1.win.1 mask. No shutdown. We can create loop back 1.1.1/32. Let's create loop back 192.168 10.1 mask. Show IP interface brief. I'm trying to advertise these networks into OSPF protocol. Okay, so router OSPF process ID. Remember OSPF configuration from Ccnp training? UNC.
Mm,
So
yes.
router OSPF 5 and then network 10.1.12.0 wildcard mask. And this network I'm trying to advertise in OSPF area 0. Now network 1.1.1.1 wildcard mask area 0. And yes, we have one more loopback 192.168 10.0 wildcard mask area 0. Let's go to our do router 0/0 interface 10.1.12.2 mask no shutdown interface loopback 0 2.2.2.2 mask interface loopback 1 192.168.20.1 mask. Now show IP interface brief. Router OSPF process ID 10.1.12.0 wildcard mask area 0. Loopback we can advertise in area 0 192.168 20.0 network area 0. Now we can verify our neighbor table information, routing table information, show IP, OSPF neighbor command. Yes, we have a
Yeah.
full state. Show IP, OSPF neighbor. Yes, we have a full state. Let's verify the routing table information now. Show IP route OSPF. So you can see we are receiving some route information from R2.
Mm,
Let's go to R2 router and we can verify routes information from R1. Yes. And right now there is no any authentication. You can capture packet here. We can verify
yeah.
right now there is no any authentication method. So if you remember OSP of hello packet, in hello packet, Routers will match hello packet information, and in hello packet, they will also match authentication key, authentication method. So if you expand this header information right now, authentication type is null. There is no authentication method here.
No enhancement. Okay.
No authentication method. Now, what we can do, we can try to implement authentication. It's a very simple task. You can directly go to interface. And I'm talking about simple password authentication. First, I'm
Mm,
talking about simple password authentication command. So you can directly
yes.
go on interface, fast Ethernet 0/0, and you can use a command IP OSPF authentication. Okay, this is the first command you
Okay.
can use to enable authentication method on interface. Now IP OSPF authentication key, and key I'm using Ccnp 123. Now you can verify show OSPF neighbor. We have a neighbor table. We are using authentication method, but we have a neighbor table. Why? Because it's waiting for dead timer. Remember, OSPF, we have hello timer and dead timer. Dead timer is for 40 seconds. So we have a neighbor table information. Why? Because I'm waiting for dead timer. Once dead timer will expired, this R1 will lost neighbor information. See?
Okay.
So now you can see that right now this R1, you don't have any, you don't have any neighbor information. Show
Mm,
IP route OSPF. Yes, I'm not receiving any route information from R2. You can go and check on R2. So now show IP OSPF neighbor, no neighbor information, routing table, no routing information. So if R2 is required route information from R1, then he need to configure R2 administrator need to configure same authentication method and key. Let's go to interface. Interface fast Ethernet 0/0 IP OSPF authentication, IP OSPF authentication key. Now key is what? Key is CCNP1.
and P. One to say.
Done. Now we can wait for hello timer only. Hello timer is what? 10 seconds. See, hello packet information. Show IP OSP of neighbor. Yes. Show IP OSP of neighbor. Yes, we have a neighbor information. If you check your routing table, show IP route OSPF, routing table information on both the router. Show IP route OSPF. Yes. R2 is receiving information. R1 is receiving information. And if you
Mm,
go and check your so you can expand any packet here. You can expand any packet and you can see you are using authentication type is what? Simple password authentication, right?
okay.
And
Yes.
authentication data is what? CCNP 123.
Ccnp. One to say.
Yes. So I
Mm,
don't want to use clear text authentication, okay, because we have an option for encrypted authentication method. So let's delete this. Let's remove this clear text
okay.
authentication method. We can go to interface, and I'm not using clear text authentication method. Let's go to IP OSPF authentication key, IP OSPF authentication, and now we can use MD5 authentication. What is command? IP OSPF. If you type question mark, if you are looking for
Mm,
clear text
comment.
authentication, then you can use authentication key method, or you can use authentication command. If you are looking for clear text authentication, if you are looking for MD5 authentication, so you can use what? Here is a command syntax. Wait. IP OSPF authentication question mark. You need to go with this command. What? Message digest.
Yeah.
So first you can use this command to enable MD5 authentication. After that, IP OSPF, and I'm not using authentication key. No, what I'm using message digest key. So command
Okay.
syntax is little change message digest key. Now You can define key ID number, and now you can define MD5. And what is key? CCI key 123. Now you can verify neighbor table information, show IP OSP of neighbor. So date time expired. So this R1 don't have neighbor information, root information you can check. You can also verify root information and neighbor table information on R2. You're not receiving any neighbor information from R1 and root, no root information. Let's configure MD5 authentication on R2. So interface fast Ethernet 0/0. Now IP OSPF authentication message digest. IP OSPF message digest key ID number MD5. And what is key we are using? CCIE 123.
CCI want to say.
Let's wait for hello timer. Let's wait for hello timer. Wait. See hello timer. And now you can check your packet information here. You can check any latest packet information. You can expand this, and now you can see you are using what? Cryptographic option, authentication type encrypted, and you cannot verify authentication key. Clear this point? You can see
Yes, yeah.
this is
But
authentication
if
method.
okay,
This is authentication
if
routing
if
protocol.
I
Yes, yes. Any question?
I don't know if I understand very well this authentication. The rules is just for security or for packet change between two routers.
Between two rows. See what they are doing. They are exchanging root information. You can see. Okay,
Okay, okay,
root information. But if you remember OSPF hello packet information in OSPF hello packet, they will match hello timer, dead timer, IP address information, area type information, and also authentication method. Authentication on R1, we are using authentication. So if any administrator is required updates from R1, for example, R2 in our design, then R2 need to configure same authentication method and same authentication key. This is the
okay.
feature of dynamic routing protocol. If you are using dynamic routing protocol in any scenario, you have to use it. You have to use it authentication method. It is required. Okay.
Okay, thank you.
Now, this is our topic. This is our topic is called what? Routing protocol authentication. Now let's talk about redistribution concept. Redistribution concept in all protocols. We are trying to discuss redistribution. Redistribution in between RIP, OSPF, and EIGR. Let's talk about redistribution concept in these protocols. Let me create a design, okay? Wait. R1, R2, and I'm adding one more router into this design.
Okay,
Okay, so into this design, I'm using a RIP protocol in between R1 and R2. A RIP protocol in between R1 and R2, and EIGRP protocol in between R2 and R3. R2 and R3. Wait.
Okay.
Let's configure IP address and we can advertise our network. So here I'm using RIP protocol in between R1 and R2. Here I'm using EIGRP protocol in between R2 and R3. Now let's configure IP address configuration first. We can advertise our network as per design in protocols. After that, we can go for redistribution implementation. Great.
Hmm.
Now R1 interface fast Ethernet 0/0 10 dot 1 dot 12 dot 1 mask. No shutdown. We can create loopback interface 1 dot 1 dot 1 dot 1 interface loopback 1 192 168 10 dot 1 mask show IP interface brief. Let's go to
Okay.
R2 interface fast Ethernet 0/0 10 dot 1 dot 12 dot 2 mask no shutdown 0/1 10 dot 1 dot 23 dot 1 mask no shutdown show IP interface brief. Let's go to R3 interface fast Ethernet 0/1 10 dot 1 dot 23 dot 2 mask no shutdown. Now we can create loopback interface 3.3.3.3 mask. We can create one more loopback 1 192 168 30.1 mask show IP interface. Let's advertise our network now, Julian.
Yes.
R1, I'm trying to advertise R1 interfaces.
You,
Can you please wait a 2 minute only, Julian?
no problem.
2 minute only.
Okay.
Okay, Julian, can you hear me? Yeah.
Yes, I'm
Now
here.
let's prioritize our network. So R1 router version 2 network
Version 2.
3.1.12.0. We can introduce our loopback interface network 192.168.10.0 no auto summary. Let's go to R2 router and you can see R2 fast Ethernet 0/0 interface. We are trying to advertise in RIP protocol, only this interface network. So network is what? 10.1.12.0. No auto summary. Exit. Now router EIGRP 10 and network 10.1.23.0. wildcard mask. No to summary. Let's go to R3. Router AHRP 10 dot 1.23.0 wildcard mask. 3.3.3 wildcard mask. 192.168.30.1 wildcard mask. Done. So we can advertise our networks as per our design. You can see any problem in configuration and route advertisement.
No, no, no. It's clear. But
Now,
one question for router 2, we have two interfaces.
mhm.
The routing you should configure by interface or in the router.
Sorry, can you please repeat
Because
your
when
question? Can you please repeat your
I
question?
say I say the routing which we are configured the protocol
Okay.
from router 2.
Mm-hmm.
Normally we need to set two type of protocol.
Yes.
One is RIP, and the second one is AJRP
Yes.
on the different interfaces.
Yes. Different routing protocol.
Yeah, but I see when you configure the AJRP, you didn't choose the interfaces 0/1.
See, we have a IP on fast Ethernet 0/1 10.1.23.1.
Okay.
This portion we are using for AIGRP network,
AJRP.
and
Yes.
this portion we are using for RIP protocol. Okay. For
Protocol.
example, I'm
Yes.
I'm working in a design. I'm working in a network
Mm.
design where you are using or administrators are using multiple dynamic routing protocols.
Okay.
But every protocol behavior is different, right? RIP always
Mm.
works with hop count. RIP can't understand bandwidth, right? But if you
Mm.
talk about EIGRP protocol, EIGRP understand bandwidth. EIGRP, OSPF protocol, they work with bandwidth, right? High bandwidth,
Okay.
least cost, best route, right? So
Yes.
EIGRP, OSPF, they work with the bandwidth, but RIP can't understand bandwidth. RIP always work with hop count. Now, so here into this design, we complete our IP address configuration, route advertisement. Now, in case if I'm trying to verify, in case if I'm trying to verify route information, so you can see I am not
Oh, okay.
I am not receiving R1 loopback here on R3, right? Do you can see?
Yes. Yes.
And if you check here on R1, I'm not receiving show IP route. I am not
The,
receiving any
the
back route information from R3, right? No. But if you
yes.
if you go and check on R2, yes, you are using two protocols, RIP
Yes.
and what? EIGRP. So now, if
Yes.
you
Yeah.
use your show IP route command, so you can see you are receiving route information from R1, right? From this
Yes.
RIP routes, and from this side, you are receiving some route with flag what? D. D flag means what? EIGRP protocol, right? So R2
Yes.
is receiving RIP routes information and EIGRP route information. But but you can see both protocol behavior is different. That's why routes are not exchanging from R2 to R3,
And three.
R2 to R1. So routes are
Oh,
not exchanging. That's why into this type of scenario, we can go with redistribution concept. If you want to exchange different routing
okay.
protocol information with each other, you can see. If you want to
Yes.
exchange
I know.
routing protocol information with each other, then you
Mhm.
can go with redistribution concept. Clear my point?
I get your point now. Very
Now,
clear.
now where we can configure redistribution concept. So into this small design, you need to search common router into the small design. You need to
Yeah.
search
R2.
common router into this design. R2 is a common router. Why? Because on
Yeah.
R2, we have two protocols, RIP and EIGRP, right?
Happy. Yes.
That's why it's a common router. So you can go to your common router R2. And now what I'm doing, I want to redistribute. I want to redistribute RIP protocol into EIGRP, RIP protocol into EIGRP, then EIGRP protocol, EIGRP protocol into RIP, into
Mm.
RIP. This is our task. So let's do
Okay.
this task first. I want to redistribute RIP protocol into EIGRP. How to redistribute? You can go to R2 router, and I want to distribute RIP protocol into EIGRP. So you can go to EIGRP protocol router, EIGRP autonomous system number. And what is the command? Command is redistribute. Now you can type question mark. You can select your protocol. For example, BGP, connected, EIGRP, multiple protocols option you have. Right now, I want to redistribute RIP protocol. So redistribute RIP command you can use.
Okay.
Now, if you remember EIGRP concept, so in EIGRP, it's work with bandwidth, delay, load, reliability, MTU. Remember
Yes.
key values in EIGRP? So here you can use redistribute RIP, and now question mark you can define metric. You need to
Okay.
metric. Yes. So metric. And what is EIGRP metric? So we can define key values. First, bandwidth.
And it.
First, we can define bandwidth, delay, load, reliability, MTU. These information I am adding into this RIP roots. So metric bandwidth I'm giving, for example, 100, question mark. Now you can configure delay, for example, I'm using 100, question mark. Reliability, I'm using 255. Now question mark. What loading? I'm using 255 and MTU size 1500. You can press enter. This is the command
Mm.
syntax to redistribute RIP protocol into EIGRP. Now, in case if you want to redistribute EIGRP protocol into RIP,
Right.
then exit. Now you can go to RIP protocol. And into this protocol, I want to redistribute
Right.
EIGRP
Yes.
protocol. So redistribute EIGRP, and what is autonomous system number? Then question mark, metric command you can use. And what is RIP metric? RIP metric is hop count. Remember?
Yes. Root.
EIGRP metric is what? Bandwidth, delay, load, reliability, MTU. But RIP metric is what? Hop count. So if you type question mark, you can define hop count metric. So now I can go with, for example, 3 hop count. Done. Done. You can verify now. You can verify now on R1 router, show IP route. This time I'm trying to verify my route information. And yes, I'm receiving route information from R3. See, this time. Clear my point? You can see
Yes.
R1 is
I
receiving
see.
now route information from R3. And now if you go
And
click on R3 this time you are receiving, let me show you. This time you can verify show IP route command, and yes, this R3 is receiving route information from R1. Okay, and you can see we have some route information with DEX code, right?
yes.
What is D code mean?
Uh,
D code means what? EIGRP route. Okay, it means it's the EIGRP route. But if you have code what? DEX, DEX, it means what? It is EIGRP external route. EIGRP external route. So this is not a EIGRP route. This is EIGRP external route. It means this route is coming from any different routing protocol.
Okay.
So you can identify here. You can identify here it is EIGRP route or it is EIGRP external route. You can verify here. If you are receiving any route information with DEX, this is not a simple EIGRP route. No, it is external route. It's coming from any other routing protocol.
Mm.
Now, EIGRP, if you remember, EIGRP administrative distance is what? 90, right?
Mm. Right.
But EIGRP external route, AD value is what? 170. This is the
Once,
170 EIGRP external route information. Now, if you check on R1 router, see on R3, my point is on R3 you can identify. On R3 you
mm,
can identify this is EIGRP external route. Routes are coming from any other different routing protocol. But
yes.
but you can see here on R1 or on R1, yes, I'm receiving some route information from R3, but I cannot say it is an external route because flag is only what? R.
Ah,
So it's like a RIP route. So
mm,
this is the problem. This is the issue with RIP protocol. In RIP
great
protocol,
protocol.
you
Okay.
cannot identify, okay, it is a RIP routes or a RIP external route. You cannot identify. This is the issue with the RIP protocol. But in EIGRP, in OSPF, right now we are talking about EIGRP. In EIGRP, whenever you are receiving any route information with DEX flag, it means this is not a EIGRP route. This is EIGRP external route. Okay, these routes are coming from different routing protocol. I hope this point is clear for you.
Yes, very clear.
Okay, now, so this is what redistribution in between RIP, EIGRP, EIGRP to RIP. Now let's go with the design. And into same design, now I'm not using EIGRP, I'm using OSPF. So wait,
Okay.
I'm trying to delete this EIGRP configuration. Now router OSPF process ID 10.1.23.0 wildcard mask area 0 network 3.3.3 wildcard mask area 0 network 192.168.30.0 wildcard mask area 0. Now let's go to R2 and no router EIGRP 10 and
Mm,
now router OSPF process ID 10.1.13.0 wildcard mask area 0. Exit. No router RIP. Okay, wait. Let's advertise RIP again. Router RIP version 2
mm.
10.1.12.0. No wildcard mask. No auto summary. Any problem in basic configuration?
No, no, it's
Okay,
okay.
now let's go to R1 again. So now if I'm trying to verify route information, get clear IP route asterisk. If I'm trying to verify route information, I'm not receiving any route information from R3. Let's go to R3. You can see I'm not receiving any route information from R1.
Mm.
I'm not receiving any route information from R1. So now I'm trying to
Yes,
configure a distribution. And yes, we have a common router. R2 is a common router, right? So
yes.
we can go to R2. And what I'm doing, I'm trying to redistribute first RIP protocol into OSPF and then we can go with OSPF protocol into RIP. So this is our task first. So you can go to router OSPF process ID, redistribute. I want to distribute RIP protocol. RIP protocol, now you can see here you can press enter, no problem. You can see. You can
Okay.
just press enter. Here you can just press enter, no problem. But if you press enter, you are getting a message. What? Only class
Okay.
networks will be redistributed. But into this design, we are not using classful IP. We are using classless IP, right? So now
Okay.
let's delete this. And I'm trying to distribute RIP protocol again. And we can use this command. What? Submit. Simple task. Redistribute protocol information subnets. If you want to distribute EIGRP, no problem. Distribute EIGRP autonomous system number, subnet. Done. Redistribute RIP, yes, redistribute RIP, subnet, done.
Okay.
Now you
But
can
it
type
is
exit. You can go into RIP protocol and I want to redistribute OSPF protocol. So redistribute OSPF process ID and yes, we need to define metric value here. So metric is what? Metric is hope count in RIP. I'm giving hope count, for example, 3. Done. You can
mm,
verify on R1, show IP route. You can verify here. You can see you are receiving root information from R3, right? 3.3.3 and
yeah.
192.160.30.1. You can also check on R3. On R3, on R3, you are receiving some new routes information. You are receiving
It,
flag is what? OE2.
oh, it too. Yeah.
In OSPF, if you are receiving any route information with O flag, this is what? Same area route, right?
Oh,
If you are receiving route information with OIA flag, this is what? Inter-area communication, right? Routes are coming from
mhm.
different area.
Okay.
Now, now you are receiving route information with OE2. OE2 means what? This is OSPF external route. This is
Yeah.
OSPF external route. Okay, this is not
Okay.
a normal OSPF route. No, it's coming from these routes are coming from different routing protocol. So we have what? We have OSPF OE2. It means what? This is OSPF external OE2. OSPF external route. Clear this
So,
point?
yeah, it's
If
clear. But I have one question.
Mhm. Any question?
If we add,
Mhm.
if we add one more router
Okay.
behind the R3
Okay.
using AGRP protocol,
Okay.
that means we have three type of protocol to
Yes.
use.
Yes. You need to redistribute only. For example, you're talking about you are using AIGRP protocol here in between R3 and R4, right?
Yes.
AIGRP,
What
no?
will be the scenario now? Because now we have two common routers.
Yes, R3 is a common router. Yes. So in a network
What?
design, you can get multiple
Mhm.
common routers. You can go to common router and you can redistribute your protocols. Clear now, my point?
Yeah, but I need to see if from router 4 we
Mhm.
can communicate directly to RIP, or this redistribution is doing only on the point-to-point router.
No, you can see if you have a big design, okay, and in your design you are using multiple different routing protocol information, multiple different routing protocol. So you need to search your common router. For example, into this design R1, R2, R3, we have two common router, right? because
Okay.
on R2 we have RIP and OSPF. On R3 we have OSPF and EIGRP. GNC. So you need to
Yes.
go on each common router in your design. After
Set
that,
this.
you can use redistribution command. Clear
Okay.
now? You can do this testing, no problem. If you face any issue, you can discuss with me.
Okay.
You can extend your design, no problem.
Okay. Now it's clear.
Clear now? Okay,
Yes, clear. That mean
Mhm.
if I configure this redistribution or R3,
Mhm.
I will be able in the R4 to see the network of R1.
Sorry, can you repeat again? Can
If
you
I
repeat again?
configure this redistribution on
Mhm.
R3,
On R3, okay?
yes, that means from R4, I can see the network of R1.
Yes, 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 you can verify. You can see.
Okay.
You need to only redistribute OSPF protocol into AIGRP, AIGRP into OSPF.
Okay. I get it. Okay.
Clear now?
Mm, now it's clear.
Now you can check here. You can check your routing table information. You are receiving some route information with OE2. This is OE2 means what? This is OSPF external route.
External. Okay.
And this is our topic, redistribution concept. This is our topic, redistribution. So what we complete? Static default routing, routing protocol authentication, and redistribution. And now we can
Okay.
focus on route summarization concept, route summarization concept in each routing protocol in RIP, OSPF, and EIGRP. We can also discuss route summarization concept in BGP, but when we will discuss BGP, we'll discuss this concept. But right now, we are working with all IGP protocols. RIP, EIGRP, OSPF, these are what? These are IGP protocols. So we can discuss route summarization here into these protocols. Let's discuss this topic tomorrow, you can see. Okay.
Okay.
And tomorrow, maybe I'm not available. Okay. I will update you today in evening. Okay. If I'm not
No
available,
problem.
then we can continue our session on Monday. Okay, Juvency?
Okay, it's okay. And one question is, I can do this all those design on packet tracer.
Packet tracer, yes, you can use packet tracer, no problem. But see,
Okay.
GNS3, you see, you can do these practicals on GNS3, no problem. But so on packet tracer, you can do this, no problem. But GNS3 will just provide you a real scenario, real configuration. Okay.
Okay.
But you can do this practical, no problem. You can use this command, packet tracer.
Okay. Thank you. I will do it.
Okay, see, let's continue our session. I will inform you, okay? If I'm not available tomorrow, I will inform you. Okay.
Okay. Let me know
Take care.
before. Yeah.
Take care. Bye.
Thank you. Bye.